Hello, geometry students. This is Unit 3, Lesson 2. Today's lesson, our essential learnings, involve determining the relationship between three special types of angles formed by a transversal cutting parallel lines. This is called the parallel line conjecture. And determining if lines are parallel based on given angles. This is called the converse of the parallel lines conjecture. So let's go ahead and get started. Okay, so take a look below. I've got two lines. I'm actually going to mark them parallel using this notation. Those two parallel lines are cut by that red line, which we call a transversal. Now, with regards to the transversal and the parallel lines form 8 angles. The exterior top angles are angle 1 and 2. The exterior bottom angles are angles 7 and 8. The 4 interior angles formed by the two parallel lines cut by the transversal are angle 3, angle 4, angle 5, and angle 6. So a transversal is a line intersecting two or more other lines in the plane. This transversal creates three types of angles, as we mentioned: exterior top, interior, and exterior bottom. Let's talk about what implications this has for our lesson today. All right, so the first type of angles formed by two parallel lines cut by a transversal are called corresponding angles. These are angles on the corresponding sides of the parallel lines as well as on the same side of the transversal. One example would be angle 2 and angle 6. Those are both on the right side of the transversal and on the upper portion of the parallel line that they come in contact with. So angle 2 and angle 6 are examples of one pair of corresponding angles. Another pairing would be angle 1 and angle 5. They're both on the upper portion of the parallel line that they come in contact with, as well as on the left side of the transversal. All right, likewise, angle 4 and angle 8. And finally, angle 3 and angle 7. All right, now you might notice that I have marked angle 1, 4, 5, and 8 with the same markings. From our previous lesson, we said that vertical angles are congruent. And what we know today, in this page specifically, is that corresponding angles are also congruent. So if corresponding angles 1 and 5 are congruent, and corresponding angles 1 and 4 are congruent, then the angles 5 and 4 are also congruent. Likewise, 5 and 8. So this 4 angle set all have congruent measures. We have different names for those, but angle 1 and angle 5, angle 4 and angle 8, angle 3 and angle 7, and angle 2 and angle 6 are all called corresponding angles. And if two parallel lines are cut by a transversal, then corresponding angles are congruent. Okay, congruent. So we could say that angle 2 is congruent to angle 6. Another way we could say that is the measure of angle 2 is equal to the measure of angle 6. We could do that for every pairing of corresponding angles. Okay, let's continue and look at a new type of angle. The next type of angle formed in this scenario with parallel lines cut by a transversal are called alternate interior angles. Two interior angles that lie on different parallel lines and opposite sides of a transversal. For example, a pair of alternate interior angles would be angle 3 and angle 6. Angle 3 and angle 6 are congruent. They are an alternate interior pair of angles. Another pair of alternate interior angles would be angle 4 and angle 5. Just like corresponding angles, alternate interior angles will also be congruent. I'm going to use a different color here. Let's go yellow. Congruent. Okay, so I could say that the measure of angle 3 is equal to the measure of angle 6, or angle 3 is congruent to angle 6. Okay, and that's because those are alternate interior angles. Likewise, I could do the same thing with 4 and 5 due to the same property. Let's look at a third type of angle called alternate exterior angles. All right, so alternate exterior angles are likely exactly what you think they're going to be. Angles exterior on the outside of the parallel lines and on opposite sides of the transversal. So angle 1 and angle 8, as well as angle 2 and angle 7. And with the same property as corresponding and alternate interior, if two parallel lines are cut by a transversal, alternate exterior angles are congruent as well. So I could say that the measure of angle 8 is equal to the measure of angle 1, or angle 8 is congruent to angle 1. This idea right here is going back to Unit 1, where we said that measures are equal, right? And objects, angles here in this case, are congruent. Okay, I could do that as well for angle 2 and angle 7, but I'm choosing to save a little bit of breath. So let's continue on to our next slide. Okay, so can we name all of the angles that are congruent? Well, I could say that the following angles are congruent. Angle 1, angle 4, angle 5, and angle 8. Those are connected by multiple reasons, right? 1 and 5 are corresponding. 1 and 8 are alternate exterior. 4 and 5 are alternate interior. 4 and 8 are corresponding. And 1 and 4 are vertical, and 5 and 8 are vertical. So there is that. We can tie those together. Likewise, 2, 3, 6, and 7 are congruent. So they all have the same measure. Okay, let's look at the parallel lines conjecture and then its converse. If two parallel lines are cut by a transversal, then corresponding angles are congruent. I'm going to use the symbol here just to save some time. Alternate interior angles are congruent, and alternate exterior angles are also congruent. Now looking at the converse, right, so let's look at the diagram for the first. Okay, there I've got parallel lines. Let's go like this, mark them parallel. And then I've got a transversal. All right, so I could say all corresponding, all alternate interior, all alternate exterior are congruent. So I could just kind of boom, boom, as a result, mark those congruent all the way around so I know what I'm dealing with. Now, as a converse, if two lines are cut by a transversal to form pairs of congruent corresponding angles, congruent alternate interior angles, or congruent alternate exterior angles, then the lines must be parallel. Okay, so let's look at that in the context of the same scenario almost. All right, so let's say I have a transversal cutting two lines. I don't know if the lines are parallel, but if these two angles right here and here are congruent, then that must be a pair of parallel lines. For example, here's a counter example of that. Let's say that I've got a transversal cutting two lines, and this angle is 48, and this angle is 46. Those are alternate exterior angles, but they're not congruent. Therefore, line 1 and line 2 would not be parallel. Okay, now if I had changed this to a 48, then I could say confidently that those two lines are parallel. Because they're alternate exterior angles, they must be congruent in measure. Okay, let's continue and look at a couple of diagrams. All right, so by a small example, I apparently mean an extremely large example. Okay, let's look at the following. Okay, first I want to bring to your attention these markings. So this tells me that those two lines are parallel. Now notice that that same line is parallel to this line, and then that same line is parallel to this line. That tells me all four of those lines. I'm going to put a marking on the edge of them. All four of these lines are parallel. Okay, now specifically, I have a transversal cutting through here. There's one transversal. And I have a second transversal over here. Okay, so when I deal, I'm only going to deal in transversal specific values. Okay, so I'm going to look at the yellow transversal and the parallel lines that are cutting it. All right, so I can tell here that A and B, those angles should be supplementary, and A should equal 64, right? Because A is vertical angle, has a vertical angle pair of 64. Now, I know that A and D are alternate exteriors, and D and 64 are corresponding angles. So I can say that A and D are congruent or equal in measure due to the fact that they are alternate exterior angles. In the same way, B and C are alternate exterior angles. So angle C should be the same as B. Okay, now A and B add to 180. So if the measure of angle A plus the measure of angle B is 180 and A is 64, that would make B 116. That would make B 116. Now notice down below that this line, and I'm pointing at this line, is also parallel to these two lines. Therefore, Q right here is actually a corresponding angle with B. You can see it right there. Right? These two lines are parallel, and Q and B are on the same side of the transversal. Therefore, Q will also be 116. Okay, now let's kind of change our view and look over here at the blue transversal. Okay, the only number that I'm given on a parallel line is 108. Okay, so 108 and E are vertical angles. So E should equal 108. 108 and F are a linear pair. So F should be 72 because 72 and 108, they add to 180. Now I'm not going to do too much extra work. I'm actually just going to do some highlighting. So I'm going to go with yellow. Notice that my obtuse angles will all match up. Right? It's kind of like a game of hopscotch almost, so to speak there. You're hopping over the transversal to the next parallel line. So all of those angle measures would either match up some way through the corresponding angles property, alternate interior angles property, alternate exterior angles property, or vertical angles. But all of those angles will be 108 degrees in measure. So that means I've got E, I've got G, oops, switch out of the highlighter mode. I got G, I got I and J and K. Okay, so likewise, I'm going to highlight, let's go blue, all the acute angles, which would be form linear pairs with all of those obtuse angles, and all of those angles will be whatever 180 minus, what would that be? 108, which would be 72. So all of those would be congruent in measure or equal in measure to angle F, which would be 72. So S and H and F would all be the same measure, 72 degrees. Again, swap back to the marker, please. There we go. S and H and F, which I already had measured. Okay, so what we've got left is angles TM, P, and N. I'll take a look at P. P is a supplementary angle, right? This angle here with this right angle. So those two should add to 180. So angle P should be 90 degrees. Angle N, you can see, is a vertical angle with 79. So those two will be equal in measure. Angle M, this little acute angle right there and 75, those add to 180, so angle M should be 105. And then finally, angle T and 61 are supplementary, also called a linear pair. Therefore, T should be 119. There you have it. That's how you use this idea of corresponding alternate interior, alternate exterior, vertical, and linear pair, also known as supplementary angles, to come up with missing angles within a massive diagram like this one. All right, guys, that's it for lesson number 2. We'll see you in the next video.